Imagine an explosion so powerful that in just a few milliseconds it releases more energy than our sun does in an entire day. Sounds like something out of a sci-fi movie, right? But this actually happens. These mysterious explosions are called fast radio bursts, or FRBs. They are like super quick and super strong radio messages coming from space. But where do they come from? Why do they happen? No one knows for sure, but in 2024, a team of scientists proposed new findings about them. They said that, in very few cases, the rapid flash that characterizes FRBs coincides with a persistent emission, which is also observed in the radio band. Working with a source of a fast radio burst discovered in 2020, which is located about 1.3 billion light-years away from us, and using most sensitive radio telescope in the world, the Very Large Array in the United States, the scientists verify the theoretical prediction that a plasma bubble is at the origin of the persistent radio emission of fast radio bursts. In theory, some fast radio bursts behaves as expected from the nebular emission model, T, which is a bubble of ionized gas that surrounds the central engine. According to the new data, the phenomenon is based on a magnetar, a strongly magnetized neutron star, or a high-accretion X-ray binary, a binary system consisting of a neutron star or black hole, accreting material from a companion star at very intense rates. The winds produced by the magnetar or the X-ray binary would be able to blow the plasma bubble, giving rise to the persistent radio emission. One of the most interesting theories is that these bursts might be linked to magnetostars. Magnetostars are very, very strange stars with magnetic fields so strong that they can cause incredible things. Let's dive into this cosmic mystery and understand a little more about these fascinating phenomena. What are fast radio bursts and how FRBs were discovered? Fast radio bursts were discovered by accident in 2007. A group of scientists was analyzing data from a radio telescope in Australia when they noticed something strange. It was a very strong radio signal, but very short. It lasted just a few milliseconds. No one knew what it was, but they soon realized it was something out of this world, literally. Since then, more than 100 of these bursts have been detected. What makes it all the more intriguing is that they come from very distant places in the universe, billions of light-years away. This means that these explosions happen in galaxies much far away from ours. What could be causing these bursts? This is the big question addressed by scientists. There are many theories, but we still don't have a definitive answer. The recent observations set that the plasma bubble as a confirmed origin of persistent radio emissions from fast radio bursts, but other sources could exist yet. Some people think that FRBs might be caused by black holes or neutron stars. Others believe they might be linked to magnetostars. Let's understand a bit more about these special stars. What are magnetostars? Magnetostars are a very rare type of neutron star. A neutron star is what's left when a very large star explodes in a supernova. They are small but very dense. A teaspoon of material from a neutron star would weigh billions of tons. Magnetostars have something extra, an extremely strong magnetic field, billions of times stronger than Earth's magnetic field. This magnetic field can cause all kinds of strange and powerful phenomena. For example, it can cause starquakes, which are explosions on the star's surface. These explosions can release enormous amounts of energy, and some people think they might be the cause of FRBs. How magnetostars might cause FRBs? When a magnetostar has one of these starquakes, it can release an incredible amount of energy in the form of radio waves. These waves travel through space, and when they reach us, they appear as a fast radio burst. This is just one theory, but it makes sense because magnetostars are known to produce other types of bursts and flashes of light. Another interesting mystery is that some FRBs happen more than once, coming from the same place in the sky. This is strange because most astronomical events, like supernovae, happen only once. If FRBs come from a magnetostar, perhaps this star is experiencing many starquakes which would cause multiple radio bursts. If the repeating FRBs really come from magnetostars, this could teach us a lot about how these stars work. Each new burst could give us more information about the star's magnetic field, about how it releases energy, and about what might be happening inside it. How do we detect FRBs? FRBs are detected by radio telescopes. These telescopes are different from the ones we use to look at stars because they capture radio waves, not visible light. When an FRB happens, the telescope picks up the signal, and scientists analyze the data to figure out where it came from and what might have caused it. One of the biggest challenges in detecting FRBs is that they happen very quickly. Often, the telescope only notices the burst after it has already passed. That's why scientists need a lot of luck and telescopes that are looking at the right place at the right time. There are radio telescopes all around the world, and many of them are always on the lookout for new FRBs. Some of the most famous places for detecting these bursts include the Arecibo Observatory in Puerto Rico, the Parkes Telescope in Australia, the Canadian Hydrogen Intensity Mapping Experiment, CHIME, in Canada, and the Very Large Array, VLA, in the United States. What can we learn from FRBs? FRBs are important because they give us a new way to study the universe. Every time one of these bursts happens, it travels billions of light years before reaching us. Along the way, the radio waves might pass through different types of matter, like gas clouds or magnetic fields, and scientists can use this information to learn more about what exists between galaxies. We are only just beginning to understand what FRBs are and where they come from. With each new discovery, scientists get closer to solving this cosmic mystery. Perhaps one day we will be able to use FRBs to learn more about magnetostars, black holes, and other incredible phenomena in the universe. With new telescopes being built, like the Square Kilometre Array, SK, which will be the largest radio telescope in the world, we will be able to detect even more FRBs. These new instruments will allow us to study these bursts in much more detail and maybe even discover new sources of FRBs that we haven't even imagined yet. As with many discoveries in science, the study of FRBs might lead to completely unexpected findings. We could learn something new about the universe that we never would have imagined before. And that's what makes the study of FRBs so exciting. The possibility of discovering something totally new and incredible. Fast radio bursts are one of the most fascinating mysteries in the universe. Even though they were discovered only recently, they have already taught us a lot about how the universe works. The idea that they might be linked to magnetostars is just one of the many theories that scientists are exploring. But one thing is certain, there is much more to learn about these cosmic explosions. The study of FRBs is a perfect example of how science helps us explore the unknown and expand our understanding of the universe. As we continue to observe and study these mysterious bursts, we can expect many new discoveries and perhaps even solve some of the biggest mysteries of the cosmos. According to the researchers, the latest finding reveals that the observed persistent emission behaves as expected by the nebular emission model, which looks like a bubble of ionized gas surrounding the central engine of the FRB. This helps to constrain the nature of the engine powering these mysterious radio bursts, which could be a magnetar or a high-accretion X-ray binary system. However, most FRBs do not exhibit persistent emissions like this investigated source. This is one of the few cases where such emission has been detected, allowing the proposed theoretical model for the origin of this phenomenon to be tested and confirmed. So, the next time you look up at the night sky, remember that out there, billions of light years away, there might be powerful and fast explosions happening that we are still trying to understand. Who knows what else the universe has to show us?